Around 500 BC, an ancient mathematician named Pythagoras came up with what we call the Pythagorean Theorem, and we use that a whole lot in geometry. The Pythagorean Theorem states that a squared plus b squared equals c squared for this particular shape right here, which happens to be a right triangle. The Pythagorean Theorem can be used to find the length of the hypotenuse of that right triangle. You'll notice that the Pythagorean Theorem is on our geometry formula sheet that we get to use for all tests and the SOL at the end of the year. We see we've got the picture of our right triangle with A and B being what we call the legs of the triangle, the ones that join together to form that right angle, and C is the hypotenuse of the triangle. We use that to find distance and length. So let's try one. The first thing I do in every right triangle when I'm using the Pythagorean Theorem is I start at the box and I draw an arrow across to the opposite side. That helps me identify which is my hypotenuse. Right triangles aren't always drawn in this really nice, neat, pretty shape. So once in a while you might see it upside down or turned a different direction, and it can be a little harder to identify the hypotenuse that way. By drawing this arrow, that prevents me from having any confusion as to which side I need to label C. Then, once I've got C labeled, I label the other two sides A and B. It really doesn't matter which one's which. Either works. C is the important one. You have to label C correctly. The other two sides, A and B, doesn't matter which order you put those two in. So, then I always write out A squared plus B squared equals C squared. That makes it pretty easy for me to just substitute those numbers there. 12 squared plus 35 squared equals x squared. Remember, I can't graph a C when I go into Desmos. So you see, all I did was I subbed 12 for A, 35 for B, and x for C to figure out what I need. So now we're going to go over to Desmos and plug this in. Okay, now in Desmos, I can just plug in my numbers. We had 12 squared plus 35 squared equals x squared. So remember, when we solve equations, we just type it all in. 12 squared plus 35 squared equals x squared. And now I'm going to look for my line. I don't see it yet. So what I'm going to do is I'm going to go ahead and zoom out a little bit. And we are only looking at the positive side because the length of a triangle can't be negative. And then I click right there on my x-axis, looking for my x-intercept, and I see that x is 37. So that's what I needed. Let's go back over to our problem. So on Desmos, we found that the x-intercept was at 37 when we put in our entire equation. That's our answer. Let's try another one. You notice with this triangle, the triangle is a little upside down right here. So not as nice and neat and pretty, but again, I start with the box and I draw my arrow straight across to identify which side I label C. And again, I can label the other sides A and B. Doesn't matter which one's which as long as it's not the hypotenuse. I write out A squared plus B squared equals C squared. And then I replace 56 for A and 33 for B and x for C. So 56 squared plus 33 squared equals x squared. Now, when I plug this one into Desmos, we get a pretty graph that looks like this. And you notice that that x-intercept is at 65, 0, which means that x value, 65, is our answer. Let's try one last one. This one is a little bit tricky. It says, which is the value of x? Again, though, I see a right triangle. I'm going to draw an arrow from my box to the hypotenuse. and I'm going to label that C. My other sides are A and B. But if you notice, I don't have a number here with A. I do, however, see tick marks. You guys remember what that means? Tick mark means congruent. So I have a 9 inches on this side, and I also have a tick mark on this other side, which means that also has to be 9 inches. So I can go ahead and write out a squared plus b squared equals c squared. I'm going to replace a and b with 9 and replace c with x. 9 squared plus 9 squared equals x squared. Then I'm going to go to Desmos, and I'm going to get a nice pretty graph back when I plug this in. That's going to look something like this. Clicking on the x-intercept, I see that x is 12.728. That's not so nice and clean, but that's okay. I do know that 12.728 is not equal to 9 or 18, so I can mark out those two answer choices. But now I've got to figure out about the other two. What I can do is I can go to Desmos and plug in the square root of 174 and see what that number is. Let's take a look. Now here, where I go to Desmos, I can plug in square root, which is on my keyboard here, and my first answer was square root of 174, and I get 13.19. Well, that doesn't look like my answer. If I plug in 9 times the square root of 2, I get 12.727. But you notice that 9 that comes after that 7, 12.7279, is going to make that round up to 12.728, which is exactly the answer that it showed us on our problem. So let's go back to it. And we see that in Desmos, the square root of 174 didn't work, but the 9 times the square root of 2 gave us 12.7279, rounding up to 12.728, which is equal to the answer I'm looking for. So that's what I pick. All right, let's practice a little bit